Alright, so those are examples of kadulamok tension members. Thereafter, diba? Dali lang. Ito, diba? Usually sa structural analysis natin, ito mga top chords natin, itong mga parts na ito ay subject to tension glass, diba? Due to the applied loads here, like dito. Yan. Diba sa mga joints lang naman nag-apply ang load sa ating trusses. Okay, can you guys hear me? Okay. So yung mga top chords natin are usually in tension. Okay, of course there are some when you analyze na merong mga naka-compression depende sa loading, but most or almost every time it is in tension. Okay, and some parts of the roof truss of course are also in tension, and we design them in tension. And of course cables, or cables cannot hold compression forces, right? So they are only used for tension. Okay, walang silbi yan if you use it for compression. So they are especially uh, used, ganyan, mga cable stayed bridges. And of course for suspension bridges, okay, itong mga parts na to, suspension, no, they hold the weight of the bridge. Itong mga to, okay, so these members are in tension, guys. Okay, I hope you can dapat red pala yung itong mga members na ito. To. Ah, so have you seen those type of bridges? I don't know if kung ang pinakamalapit sa atin na nakita ko is the Lalo Bridge sa Cagayan. Okay, and of course we have brace. We use tension members as bracing, no, dito sa mga bracings na ito sa ating buildings. Yeah, those bracings. Dali, tension ko. Alright, introduction pa rin. So the tension members can have a variety of cross sections. Okay, what are most commonly used as tension members? Okay, in industrial buildings, we use the single angle and double angle. In roof trusses, yan, no? As roof trusses, we usually use single and double angle sections. Okay? Sa bridge, okay? Sa bridge truss, okay? It is usually made of channels or high sections. Okay? Acting individually or built up. Ibig sabihin ng built up, pinagdugtong-dugtong, no? Na different sections. Right? Ano pa? Circular rods, no, are used in bracings designed to resist loads in tension only. They buckle at very low compression and are not considered effective. Okay, circular rods. Yun naman yung mga ginagamit. Ito mga to. Of course, if you see those types, no, those are circular. Okay, cables. Okay, ito naman yung subgrad, guys. Ewan ko nakakita na kayo ng ganito. Usually naman sa mga establishments, nakikita natin ito mga to. I don't know sa school, wala pang nakita sa mga roof. No, sa mga natin, merong mga rods na naka na ganyan. Okay, meron din yung mga naka-cross. Kung nakikita niyo yung mga yun, those are also used in tension. Okay, and then steel wires or steel wire ropes, okay, are used as suspenders in the cable suspended bridges and as mainstays in the cable stayed bridges. Yun pala yun. Okay, and of course, yun din yung sa mga bahay-bahay lang ba, yung cable na pang-hold. Di ba? Nag-analyze kayo sa statics ng mga ganitong problem. Say for example, this is part of the roof. Okay, be it usually, ano ba? Bubong to usually eh. Tapos merong mga cables na nakaganito. And of course, these cables also are in tension, no? Because they have to help hold this roof. Itong part na to. Ayan. So, itong mga to, dinedesign din natin. Okay, so that they can hold. Yeah, so the angle and the double angle for industrial roof trusses. Okay, for bridges and ang sabi? Bridge trusses, no? We usually use the channels and the wide flange or I shape, sabi niya, no? In individually or built up. Built up, ibig sabihin itong mga to. No? These are built up sections because ang madol. Ba't yung mga yon? Siguro ibang mga numbers yung mga nila pinaglalagay niyo dun sa ano eh, sa SIAS. Kaya pag sinesendan ko ng link, merong pumapasok. Tapos hindi naman yun yung pangalan niya. Angelica Angadol. Sino yun? Hindi ko kilala. Okay, and of course, these are bars and wire ropes. Okay, those are the cross sections for tension members. Are you guys listening? Now we go to paborito nyo, no? Stress. Wait lang ko lang tubig. Wow. Wait lang, kasi search lang ako. Okay. Let's continue. So the stress in actually loaded tension member is our basic stress formula. Now, if you remember, in our mechanics of deformable bodies, kasi ako din ang teacher noon, di ba class, ang gamit natin, that is your stress. Okay, this is your actual stress is equal to P all over A. Okay, so there is no difference what the symbol lang, no? So we also use F as stress symbol. Okay, so where P is your load magnitude or kung ano man yung value ng ating load, no? Usually in kilonewton. Okay, for the unit of force and area. Okay, that is the cross-sectional area that is normal to the load. Okay, and it is in square millimeter. Let me first. So, kilonewton. And of course, we have sometimes in English system, this is in pounds or kips, kilopounds. Okay, kips na lang tayo kasi malalaki naman yung kayang i-hold ng ating mga tension members eh. Area is in square millimeter. And in English system, we have ano ba? Square inches. Yan. And the stress in tension member is uniform throughout the cross section. Okay, but there are exceptions. Number one, okay, near the point of application of load daw class, hindi na uniform yung ating sorry. Hindi na uniform yung ating stress distribution. Okay? And at the cross section with holes, nawawala. Four bolts or other discontinuities. Mamaya, napakita natin, no? So, kung saan daw merong mga butas, okay, for bolts, no, dun sa ating mga connections, no, or for other discontinuities, okay, pwede din sa welding, okay, there will be uh, uh, changes doon sa distribution ng ating stress. Okay? So that hindi na siya magiging uniform. Ano bang ibig sabihin ng uniform, sir? Di ba? For example, ano pwedeng ano natin? Sa plate na lang. Challenging na naman dito mag-drawing. Okay. So if this is a plate, guys. Okay. The stress distribution daw ay uniform all throughout. So paano yung stress distribution? Uniform lang siya. Okay, but not at the point of dun sa dito daw sa bandang malapit sa ating application ng load if it is applied here. Usually naman sa ends yan kasi we are considering a full structure, okay, and we are just to analyze members. Dun sa end-to-end yung application ng ating load class, right? So, and doon sa mga may connections, if we have, kung magbubutas tayo dito for bolts or tornilyo, ganyan, okay, there will be changes in the distribution of stress here. Okay, kasi nga, bakit ganito? Dito. For example, dito may butas. Nagiging ganito siya. Mm. Ano ba i-drawing yung may butas? Like that. Na okay, kung yan yung dadaanan ng tornilyo, guys. Ito na lang yung member na dadaanan ng ating tension stress, no? Or yung may stress na part ng ating member doon sa ating mga connections so that magkakaroon na ng diferensya sa ating stress. Okay, hindi na siya magiging uniform. And we have the tension strength. Ano yung tension strength, diba? If we have F is equal to P all over A, our P is basically equal to your stress times the cross-sectional area. Okay, so as the load continues to increase, one of the following occurs. Okay, number 1, 2, 3. These are our failure states. Meron tayong tatlo. Ano mga pwedeng mangyayari? The cross-section yields, that's number 1, no? Possibly leading to excessive deformation. So kapag daw, dinagdagan pa natin ng dinagdagan yung load. Okay, it will have excessive deformation. Okay, ito yung figure. Yung pinakataas, figure 1. Wala. Okay, so makadangdang, pwede mong i-off muna yung yung mic mo. Ay, yung tawag nito. Cam mo. Naka-open. Okay, so that's number 1. That's yield failure. That's or yielding of the cross-section. Okay, so if you remember your stress strain diagram, class, diba? This is your strain and this is your stress. Right? So, paano yung ating figure? Linear siya under the hanggang sa proportional limit, and then you'll have ganyan siya, and then simplified. Ganyan. Simplified lang. So that here the stress is basically equal to Fy. Can you guys hear me? Okay, and dito sa my rupture part, the stress here is your F sub u, or your maximum stress. Okay, so cross-section yields, hanggang dito lang siya. No? So magkakaroon na daw siya ng excessive deformation if it attains this Fy. Pagkatapos kasi nun, magiging plastic na yung ating deformation. Ibig sabihin, if lumampas na siya ng Fy, mangyayari niyan is, tawag nito, magkakaroon pa ng excessive deformation, okay, without even changing much yung load. Okay, at yung deformation class, kapag tinanggal mo na yung load, hindi na siya basically babalik doon sa dati. So, nagiging plastic na siya. So, hanggang dito lang naman yung ina-analyze natin dyan, cross-section yielding. So, basically, doon sa gross area nangyayari yan. Doon sa cross-section. That's number 1. Karalan natin kung paano yung mga ano dyan. Number 2, okay, the cross-section through the bolt holes ruptures. Doon daw sa mga connections natin, no? We look at this figure. Meron tayong mga bolt holes dito. Okay, dito yung cross-section yielding class, no? So, yung cross-section natin, okay, nagkakaroon ng excessive deformation. That's number 1, failure. Number 2, rupture failure. Ibig sabihin, napuputol daw siya doon sa ating mga connections. Dito sa bolted, okay, pwede din sa welded class, no? Pwede din siya maputol doon sa pinag-weldingan. Okay, so this is rupture failure. So it results in a loss of integrity of the structure. Of course, mag-fail na siya, no? Kapag naputol, will not serve its purpose anymore. Number 3 is what we call a block shear. That is when a cross-section through the bolt holes fails in combination of shear and tension. Diba? That's figure number 3. Kung ito yung load natin, P. Okay? Itong part na ito, class, this part here na naputol, this is still rupture class or failure, but combination of shear and tension. This part, class, diba? Ano ba ang shear? Sliding. Naputol siya, so there is sliding on this part kasi it is parallel to the load. Ito naman, it is perpendicular to the load, so that this is steering or tension naman yung nangyari dito. So combination, nagkaroon siya ng block shear failure. Ganun naman yun. Okay. Yung rupture, okay, or net section, tawag kasi natin dyan, net section rupture or fracture in the net section, dito lang napuputol siya along the tension side, right? Or perpendicular to the load. Ito yung load mo. Okay, and then we have the nominal strength. Of course, kung meron tayong nominal moment, ganyan-ganyan, no? That is also nominal strength doon sa ating RCD. Okay, we also have that in our steel. Okay, so tension members, yielding in the cross sections. Yan yung number 1, ano natin, di ba? Failure. Number 1, failure mode. Okay, dalawa kasi yan eh. We have serviceability conditions or considerations, yung excessive deformations natin yan, meron yung sinasabi si NSCP. Mamaya. The next, ano pala yun, sa design. No? May nire-require sa NSCP na ang ating deflection sa ating member should not exceed LL over 300. No? Then number 2 is the serviceability and safety. Okay, safety, ito naman yun, yung kinicheck natin. Cross-section yielding, bolt hole rupture, and block shear. Dapat chinecheck natin na yung ating member ay kaya niyang i-hold. Or kaya niyang ano yung mga failure na ito. Or dapat hindi niya ma-reach. Anong dapat? Okay. Cross-section yielding. Number 1. What is the formula? This is your basic formula. Because cross-section yung pinag-uusapan natin, doon magkakaroon ng failure. Okay, ang cross-section class is yung buong section, no? Without considering the mga butas-butas. Okay, yung gross. That's AG. Okay, your PN, this is taken from your F is equal to P all over A. Okay, if F is your yield stress Fy, your P is your nominal strength divided by AG, that is your gross area. So the PN is equal to Fy AG. Okay, number 2, that is your rupture in the net section. Your nominal strength for net section rupture class is, sorry, FUAE. Diba sabi nga natin, okay, magkakaroon ng fracture dito or madi-disintegrate na yung ating member, mapuputol siya dito. Kaya namang sabi sa ating stress strain diagram pagdating dyan, dito na yung part na na-attain ng ating stress pagdating doon. So that we use the FU. Okay? Yung FU na yung gagamitin natin. This is not FY, this is FU. Okay? So PN is your nominal strength in the net section. FU is your ultimate stress. AE is equal to UAN. Okay? We will also discuss what are those or what is that formula. AE is your effective net area. Okay? And U is our reduction coefficient. Klase. Alright, so this is our tensile strength after computing for our our PN plus. No? Ito nire-require ng ating code. Okay? Diba ito, sa ating LRFD, this is the load combination. Okay, load factor combination. Doon galing sa ating code. No? Yun yung mga ilo-load natin sa ating structure. Sinasabi, dapat it should be less than or equal to your nominal strength. Okay, ito yung kakayahan ng iyong member to hold tensile strength. No? Multiplied by your ano tawag dyan? Reduction factor or LRFD, load and resistance factor. That is your resistance factor. So you have to multiply that by phi. At ang sinasabi sa ating class, if it is cross-section yielding, ang phi natin is 0.9. Okay, 90% pagdating sa cross-section yielding. Okay? And for ASD class, our allowable, this is your service loads, no? Kung ano yung binibigay ng code, pinagpa-plus lang natin sila, then that would be our service load. And it should be less than or equal to our allowable strength. Tama ba? Ito yung tawag doon. This is your allowable strength, Pn divided by omega naman, where omega is your factor of safety as was discussed in your module 1. So that, diba, sa gross section yielding, sinasabi, ang ating omega daw ay 1.67 lang. Okay? That's about, lang ngayon, 5/3. Okay? Tama, 5/3. Okay, or 1.67 yung gamit natin. Pagdating sa net section rupture, okay, if we are ito yung formula natin dyan, no? YAG for gross section yielding and FUAE, malit ba sa inyong part lang? Yan, okay, siguro yan. Okay, for net section rupture class or fracture, okay, ang factor of safety natin for the ASD or allowable stress design is 2.0. Okay, for rupture, okay, using LRFD, is 75% daw ang kinukuha natin na strength. Okay, 75% of strength in rupture or 0.75 na lang yung ating reduction factor. Okay. So yan ha, tandaan nyo lagi ito. Dapat hindi kayo balito. Okay, kapag yielding, okay, you use 1.67 for omega and 0.94 for NRFD. Okay, for net section rupture, Okay, you use 2.0. Okay, 2.0 means a greater factor of safety, no? And 0.75 for the LRFT. So, what explains why sa ating LRFD, okay, mas mababa yung ating resistance factor, okay, for rupture rather compared to yielding. Okay, sabi dito, it reflects the more serious nature and consequences of reaching the fracture limit state. Of course, no, kapag kasi sa yield rupture, okay, hanggang dito pa lang naman siya. Dito, FYAG. Eh, ang ating rupture, dito na, yung mapuputol na yung ating member. So, delikado yun. So that, inabaan talaga yung ating factor doon. 0.75 lang, sabi ng ating MS60. Okay, so the side strength will be the lesser value of the strength for the two limit states. Okay, for gross section yielding and net section yielding. Bakit, sir? Okay, we always consider these two. Okay, gross section yielding tsaka net section rupture. At kung sino yung mas mababang value sa kanila, yun yung mag-go-board sa ating design strength. Okay, yun yung ating design strength ng ating member. Bakit, sir? Kung yung gross section yielding ang ating mas mababa, so for example, for gross section yielding, ang na-compute mong strength is 100 kilonewton. At for net section rupture, we have 150 kilonewton. Okay, the governing failure will be rupture in the net section. Okay, so that ang design strength natin will be 150. 100 kilonewton. Okay, gross section yielding ang mag-govern na failure mode. Bakit, sir? Okay, bago pa niya class maabot yung 150 kilonewton na load, okay, nag-fail na siya sa yielding. Right? Nag-fail na siya sa yielding. So that, di na niya maabot ito, 150 kilonewton. Okay? So if you are to ask me, sir, ano yung usually na mag-govern, we have to investigate, no? Para masagot natin after solving a lot of problems, no? After this module, edi ma-assess natin kung ano yung usually na nag-govern na failure. Is it gross section yielding or net section rupture? Of course, we still have the one, yung block shear. 22. Tapos nag-leave pa si Harvey. Okay. Gross area is the original unaltered cross-sectional area of the member. Okay? So, saan mo kukunin yung gross area? Dito sa part na to. Yung mga, eto. Okay? Mga part na to. Dito yung gross area. Yung hindi na-alter yung ating original section. Okay? Yan, kinukuha ang gross area class. Of course, you are looking at the side. Tama ba? Side elevation. Okay? So, if you look at the isometry, eto siya. Yung part dito sa may butas. Etong section na ito. Francis Calino has left the group. Okay? Dito naman, ito yung section na pinapakita dito. And this is your net area, yung shaded part. Itong part na ito. Okay, this is what we call a shaded area. If our section is a plate, ganyan siya. Kung mayroon siyang tornilyo, okay, or bolts. The net area is the cross-sectional area of the member minus the holes or notches. Since dito mayroong butas, no, kung saan maglalagay tayo ng bolts, di mabubutas dyan. Di ma-minus natin yung area ng butas. Paano i-minus, sir? Hindi yan pi r squared class. No? So we have to look at the section kung paano yung magiging butas niya. Then, ito lang naman yung area na yun na butas. Itong rectangle ito. Diba? That would be the diameter of the circle. Diba? Kung ito yung diameter ng ating butas, diameter t, okay, multiplied by the thickness of the plate t. Diba? Yun lang naman yun. And ganun din sa baba kasi dalawang line yung ating butas. Okay. Now, what is the net area? Yun na nga pala yung lip area. Okay. So, net area is logically the cross-sectional area actually available to be stressed in tension. So, yun na lang yung kayang yung pwede mong i-stress. Yung nominal hole dimension, ito yung part na ito. Okay, that is, if your bolt diameter is 1 inch, you add another 1/16 inch. That is the nominal hole dimension. Dito lang tayo sa standard class. Okay, we consider later sa connections itong oversized, short slot, and long slot. Okay. Di ba sabi natin, we just add 1/16. Sa NSCP natin class, ang nire-require is, if our bolt diameter is 16 mm, our nominal hole should be 18 mm. Plus, okay, punching damages, sabi ni NSCP, in computing the net area for tension and shear, the width of a bolt hole shall be taken 2 mm greater than the nominal dimension. This is the nominal hole dimension. So, kung 16 mm yung ating bolt, okay, magbutas tayo ng 18 mm plus damages, okay, should be taken 2 mm larger pa daw. So, 18 plus 2 ka pa para doon sa ating diameter of the bolt hole. Okay? So, 18 plus 2 na yun. Yung sabihin 20. So, hanggang, wait lang, erasin ko. Hanggang 22 mm. Okay, so kapag 24 mm na yung ating bolt, okay, plus 3 na siya dito sa standard diameter. 27 plus 3, 30. Pero plus 2 pa rin doon sa pangalawa class dito sa punching damage. Okay? So 30, 33 na siya, plus 2 pa di plus 5 na yung total nun kasi ito. So, doon, kapag doon sa libro, that would be, kunyari, 16 mm. 16 plus 1.6 plus 1.6 lang sana, 16 plus 3.2. Okay? If we follow the NSCP, M16, standard diameter, that would be 18 or ganito kasi yan. Kung 16 mm yung ating the standard diameter or nominal hole dimension would be 18, D plus 2 yan. Okay, plus, okay, for punching damages 2 mm greater, plus 2 pa. So, ang nangyayari, 16 plus 4. Okay? Kapag nang tumaas, 24 mm na yung ating bolt diameter, magiging plus 3 plus 2 na yun, di plus 5 na siya. Hindi na siya plus 4. Ganun yun plus. So, we have to follow this table. Alright? Sir, paano kung yung bolt diameter namin 17 mm, ganun, 19 mm? Hindi ganun pa rin if it lies on this, plus 2 pa rin naman siya dito, di plus 2 pa rin. What's next? Alright. So, yan. Sa textbook natin, that's the diameter of the bolt plus 1.6 plus 1.6. Okay. Diameter ng hole pala, tawag dito, DH, hole diameter. Okay? It would be taken as the nominal standard hole dimension, that is the diameter of bolt plus 2 or plus 3. Depende sa ating bolt diameter. Okay, plus 2 or plus 3, we follow the standard. Okay, plus 2 mm as required by the NSCP. Right? So we have example here. So if you notice, our examples are expressed in inches, no? So we have to convert them into mm's and kilonewtons. Because usual, wala pa kasi ako nakikita class na maraming libro na naka-convert na siya sa SI. So mga resources usually na ginagamit naka-English system lahat. But since we use the SI system dito sa Pilipinas, we have to convert them. Ito. So we have a then top section, no? If you look at this is a tension member. Okay, so the loads act away from each section or cut. So, ito. Meron tayong plate sa taas and then plate sa baba. And then we have this thick plate. PL stands for plate. Rectangular. Then, Walang pinaiimbestigahan. Determine the net area in the plate zone. The plate is connected at its ends with two lines of 3/4 volts. Determine the net area of the 3/8 by 8 inches plate. So itong part na ito, itong malaki. No? Kukunin daw natin yung kanyang net area. So saan ang net area? Doon sa meron tayong butas. So since pare-parehas lang din naman yan, we just consider one section. If we cut through here, yan. Nangyayari niyan, diba? Ganyan siya. Or video. Okay. Pagpatensyahan nyo na yung drawing ko. Ang ganda-ganda. Ganyan. Okay. So, 3/8 by 8 inches. Of course, yung thickness niya, yun yung 3/8. 3/8 yan. Ano ang 3/8 inches sa mm? It is equal to times 25.4, or conversion class is 1 inch is equal to 25.4 mm. Baka hindi nyo pa alam, no? Or 2.54 centimeters. Alright? So, we have to convert them. 3/8, that's 9.525. Sorry. Or, sige, kunin na lang natin yung lahat. 525 mm. Okay, and ito, yung total depth is 8 inches. Okay, so 8 inches, that is equivalent to 8 times 25.4. I hope you are following me. That is 203.2 mm. Ganyan natin. Ganyan. Alright. So, ano yung net area? Ito yung part na ito. Okay. So, ano ang ating magiging hole diameter? Ano yung diameter ng bolts na sinabi? That's 3/4 inches. Okay, 3/4 inch in mm is equal to what? Okay. Pakibigay nga anong value ng 3/4 inch in millimeters. Anyone? $19.05. Okay. So 3/4 inch is equal to 19.05 mm. Ayan. So 19.05 daw yung ating bolt. But ano ang magiging hole diameter natin? Okay. Yung 19 mm. So we have to look at the table. Anong magiging standard nominal hole dimension natin? That would be, yan, sinasabi ko kanina, di ba? Okay. 16 mm and 20 mm. Dito naglalay yung ating 19 mm between them. Okay, pero for 16, nag-plus to lang din naman siya. For 20, nag-plus to lang din naman siya, no? So for the 3/4 inch or 19.05 mm, mag-plus to lang din tayo for the nominal hole dimension. Okay? So, 19.05 plus 2 mm plus, kaya sabi ng NSCP, kailangan pa natin mag-add pa ng another 2 mm. Okay, so ilan na to? 19 plus 4, 23.05. Okay? Mm. Alright. Pwede naman dito siguro yung 3/8 inch natin. Pwede natin gawing 9.5 mm lang. Yung 3/4 dito, pwede yung 19 mm lang. Pwede yun. Or 19.1. Alright. That's the diameter of the hole. 23.05. And then, meron na tayong thickness. Pwede na natin i-compute yung net area. net area natin is equal to the gross area plus gross area, yung buong area natin. Then, i-minus lang natin yung mga area ng butas or area of holes. Okay? Yan yung area ng holes. At ano ang area ng holes? That would be 9.525 multiplied by ito, saka dun sa baba na doon na ngayon, 23.05. Ito, ito. These are 23.05. So, ang gross area natin, 203.2 multiplied by, I hope nabawasan nyo na mabuti yung sulat ko. Mukhang hindi. Masyado yata makapal yung ballpen ko. Multiplied by 9.525. Okay, minus area ng butas, dalawang 23.05 multiplied by 9.525 mm. Okay? Yan. So please give me the answer, Mr. Aquino, Raven. Ano ang ating net area? Please calculate. Mr. Aquino, nandyan ba? Sir, nag-CR po siya. Okay, yung asawa niya siguro yun. Anyone, Miss Galasinaw.
Sir, wait.
Okay, pag nagkaklase tayo, dapat lagi yung hawak calculator. Anong sagot?
For 96.37, sir, or 30.
Okay. 1496 point. Okay, let's just say 0.4, no? Kasi a decimal of an mm squared is napakaliit. Nawala yung aking presentation. Ayan. Okay, so let's just consider 1496.4 or sometimes 1496 lang yan, no? Kasi napakaliit naman yung 0.4 square millimeter, di ba? Can you imagine that?
Sige, sabihin ko na lang.
Alam mo na lang, tama na. Baka mapunta pa
Wala
yung
pa talaga eh. Natapos na ngayong
Yung-
init lang gabi. Iinit na naman yan. Mamaya si Geneva na
Yung-
mag-decide ng kung ano-ano.
Makaaway na kayo ni Gineva, hindi ka na makapunta doon.
Anong wag nilang gawin yan? Gagawin talaga nila.
Ano, tampira, ba't sino ka ba? Sasantuhin ka. Ano ba meron sa'yo?
Kung ano nung pinakamunan na nag-init tayo dito eh.
Jason, paki-ano yung mic mo? Paki-off.
Wala naka-off.
Alright. So yun yung sagot natin, no? For the net area, 1496.4 square millimeter. Ayan. Okay lang yan, Jason. Alright. So example 2. Okay, we have a T section, no? That's WT 10.5 by 61. Okay, of course, hati yan ng ating WT. So we look at Kailangan pala dito ko ipakita. This section of WP 10.5 by 61, that would be yung kalahati ng section na W 10.5 by 2, that would be 11 by 61 times 2, 100, but 122. Okay, so let us look on this section W11 by 122. Kalahati lang yan is our section. Saan ko ba i-open dito sila? Office. Na AISC. Ito, sections database. Kevin Rafael. Plus 11 na pala. Wala pa akong nadidiscuss. Okay. So, ano nga sabi? Ang section yung hanapin natin? W11 by 22. No, 10.5 times 2 is what? 21. W21 by 122. Ganito class, no? I hope in-open nyo na yung AISC. AISC is shape database. W21. Hanapin natin. Dito yung W21, no? Ayan. W21y. Ano yun? 122. So ito. So kalahati niya would be WP kasi hatiin mo sa gitna. No? Nagiging T-shape na siya. So ito. And then you have to look for its properties. Yung gross area. Yan lang naman. Kaya dito siya. This is the weight. Okay, so it is 122 pounds per feet. Okay, pero sa SI, it is 182 kilograms per meter. And its gross area is 23,200 for the W section, no? 23,200. So area is equal to 23,200. So that's for the W section. Kapag WP na plus, edi ang gross area niya would be half of 23,200 kasi tinuto lang naman siya na. So 23,200 divided by 2, that is equal to 11,600 square millimeter. I hope na ginagawa ko po ito. And then model of the level gauge. Ano ang level gauge in millimeter is 22.22. It's just point. 20 point. Hindi na may imagine yung 0.22 mm, di ba? Yeah, ano natin consider yung 0.02. 20.2 mm. Ayan. So, ano magiging diameter natin? That will be 22.2 plus 2. And then plus 2 pa. Okay, plus 4 na siya. Pagbubuan. So that the whole or diameter natin dapat will be 26.2 mm. Now, what is our net area? Ito na yung gross area ng ating T-section minus D. Kaya area ng ating mga butas. So, net area is equal to the gross area ng area ng holes. Which is equal to 11,600 minus area ng holes tatlong what? Per weight lang. Pagkakaiba ang mga lunge techniques na saka weightness ng mga technique natin, ha? Thickness of the lunge. This is lunge weight thickness, TFF, and TW. DW or thickness of the web 15.2 mm. Yan, 15.2 mm. Tapos yung plastic lens is at 24.4 plus 24.4 siya. 24.4 mm. And then next time, for -3. Okay. So sa web, tira yung minus area ng code with 6.22. Okay, better. Kasi ka, kita. Net area A sa 10 is equal to the gross area minus area ng butas. That is equal to 11,600 minus una dito sa web 15.2 by diameter ng hole 26.2 minus dalawa sa flange 2 times 24.4 multiplied by diameter ng hole 26.2. Okay, so please give me the value of the net area. So, importante yan, no? Dapat marunong kayo mag-compute ng net area natin para masolve natin yung mga susunod na hakbang. Okay, Mr. Martinez, sana may hawak ka dyan na calculator. Pag-compute. RB. Na value. Kahit sino na lang. Ano compute lang?
9923.2, sir.
923.2. Square millimeter. Right? So, yan ang ating sagot. Okay. Now we have the staggered connection. So, ano mangyayari kapag meron tayong stagger or staggering holes? So, sometimes, okay, yung ating mga bolt holes ay naka-staggered daw, hindi daw siya dire-diretso na. Yung stagger, meron silang, yung nakasigsag ba, no? Yung mga butas natin. So, we have this, okay, bolt holes to be in staggered. No? So, staggering of the holes increases the net section, okay, or net area of the section. Pinapataas daw niya. By what intensity? Okay, this is by S squared all over 4G. Ano yan? S is our, ito yung binigay dito. By 4 chain of holes extending across the part in any diagonal or zigzag line. Nagre The net width of the part shall be obtained by deducting from the gross width the sum of the diameters or slot dimensions as provided in section 510.3.2 of your NSAP, chapter 5, of all holes in the chain, and adding for each gauge space in the chain the quantity S squared all over 4G. Ano yung S? Okay, that is the center to center distance of our bolts, no? Okay, parallel to the load natin. Kung ito yung ating load P, o yung parallel na section sa kanya, okay, center to center distance. So parallel, ibig sabihin yung parallel na lang tawag natin sa kanya. Pero kasi meron din naman tayong pataas or pa-diagonal na sections eh. So parallel sa kanya, okay, this distance would be our S. Okay? Wala ba yung explain dito kung ano yun? Wala. And then, meron tawag dito, pitch na ito. Dali lang check ko. Ba't di ko kasi nilagay? Para may lagay ko dito. Sandali lang. Yung libro ni McCormack. Analysis of tension. Okay, teka nga. Zigzag. In this expression, S is the longitudinal spacing or what we call pitch. Okay? Ito, class ay dagdag natin. S is the longitudinal spacing. Kaya na yung longitudinal, kasi yung longitudinal section, of course, yung mahabang part ng ating member. So, this is pitch. And then, G is our gauge. G is our transverse spacing. Spacing nung center to center ng ating bolts class. Transverse spacing. Or what we call gauge or G. So, yan. So, kailangan daw natin idagdag ito sa ating area. Okay? Whatever the thickness is, no? Kung ito yung plate natin, di may thickness yan. Okay, sa area, idadagdag natin. Okay, this is the added width ng ating net section. We multiply that by the thickness. Okay, ito. Ganyan. Okay, for example, we are to compute the net area if the plate is 1/2 inch thick and the bolt diameter is 3/4 inch. Okay, CR break muna tayo. 2 minutes, 11:24, 26. Naigi ako. Hindi mo. Ay, nagkantamot tayo. Dagang 30 na. Right, let's continue. Here. Okay. We have this example, number 3. We are to compute the net area. Parang ni Gray. The plate is 1/2 inch thick and the diameter of the bolt is 3/4 inch. Of course, yung thickness na yon, yung hindi nyo nakikita, no? Perpendicular to the paper. Okay, that's 1/2 inch. So if we extend this drawing, yun. Parang ni Gray. Class. Yan. Huh? So yung thickness na yan is 1/2 inch. Or in millimeters is equal to 0.5 times 35.4, 12.7. Okay, of course, we have to convert each into mm. 3 times 25.4 is 76.2. 2.5 inches is 63.5 mm is 3-inch is 76.2. So this is 76.2. Makadangdang left to group. And 2.5 is 63.5 mm. Okay? So naka-mm na yan. Compute the net area. So eto, meron na tayong stagger. Okay? So, paano natin yan i-compute? You have to consider each failure plane. No? So, paano? It could be what? A, C, D failure. So we have to consider our failure lines. Number 1 is line A, B, C, D. What is another failure line? Pwedeng A, yan. Pwedeng A, B, C, F, and yun. Or A, B, C, E, F. Diba? That is another failure line. So we consider line A, B, C, E, and F. Okay, and then lastly, we have the other line. No? Nung line yon, A, V, E, tapos F. Ganyang figure line. So that is line A, B, E, F. Okay, so consider natin sila. Kung ano yung ulit yun? Wait lang. Nalilito ako. Pinaka mababa. Yun yung ating i-consider. Okay, first lang. Wait lang. Yung diameter ng hole natin na ito. Calculate. Diameter ng hole, anong 3/4 inch ulit natin? 3/4 is 19 ba? Times 25.4, 19.05, 19 mm na lang. Alright, hole diameter natin, 19 plus 2 mm plus another 2 mm. So that is equal to 23 mm yung hole diameter natin. Okay. First, we consider line ABCD. Okay. So, net area is equal to gross area natin. That would be equal to, ano yung kabuuan ng 11 inch? 11 times 25.4. That's 279.4 mm. No? So, kung pagka-add nyo ito, itong apat na ito dapat equivalent to 279.4 mm. Tagarin mga kita nga manukin. Okay, so line ABCD. Ito yon, line A, B, C, and D. So, diretso lang. Plus, no? Minus dalawang butas. So, gross area natin, that is equal to, ano yung gross area? 279.4 multiplied by the thickness, 12.7. Okay, minus, okay, di ba? Line ABCD, meron lang tayong dalawang butas. That would be equal to minus 2 times hole diameter, 23 mm, multiplied by the thickness ng ating plate. That's 12.7. And that is equal to less 2 by 23 by 12.7. Okay, please correct me if I'm right. 2,964.18. Point 2 na lang. Square millimeter. Sometimes, tanggal ko na yung point something sa ano. Nira-round up ko na lang sa hole. Kasi guys, napakaliit naman ng 1 square millimeter. Para maepektuhan niya ng sobra yung ating strength ng ating member. Consider, bigyan na lang natin 2,964 square millimeter. Right? And then another line, line A, B, C, E, F. Okay. Ito yung line na yun. Tagari, klase ako. Okay, ano yung line A, B, C, E, F? Ito yun. A, B, C, E, F. So, meron na tayong zigzag dito, class. So, we have to consider S squared over 4G. Right? So, net area is equal to our gross area, that's 279.4 by 12.7 mm minus ilan yung ating butas lang holes yung dadaanan sa dalawa at saka tatlo from B, C, and E. So, tatlong butas, that's diameter of hole, 23. I hope you guys are with me. 9, 10, 11, 12, 13. Ay, nag-busted kayo on. 19. 18 lang. Bahala kayo, nagla-line kayo gaya. Sana pumasa kayo. Then, plus. Okay, na-minus na natin yung tatlong butas. And then, we have to add the stagger effect. That's S squared over 4G. Okay, ano yung S natin? Longitudinal spacing or yung gauge. Okay, that is 3 inch. Ito yung S natin. No? At meron tayong G. Ito yung G natin. That's equal to 3 inch din, no? So, plus S squared okay, plus S squared, that would be 76.2 mm squared divided by 4 times the gauge. Okay, gauge pala yung S. That is 3 inch or 76.2 din. Okay, mm. Alright. Now, we have to multiply that by the thickness. Okay, that's 12.7 mm. Okay, para maging area din lang siya. So, that's line A, B, C, E, F. And please compute the net area. So basically, ganito lang yan. The net area is equal to the gross area minus area of the holes, okay, plus, okay, kung ilan mang stagger yan, S squared all over 4G multiplied by the thickness, okay, ng ating plate or kung ano mang material yan. Please compute the net area. Anyone can answer?
Sir, 2,914.
Square millimeters. Tama ba? Nakuha ba ng lahat? Wait lang, di pa ako tapos nag-compute.
Sir, 2703.8 naman po sa akin.
Yung lalaban na. 76.2, wait lang. 76.2 squared over 4 times 76.2 multiplied by 12.7. 2914. Eh, naman, pukaw. 2914 class, please check. Okay. So, yun. 2914 square millimeter. At hindi pa dyan nagtatapos. Of course, we still have the last line. Meron bang space dito sa next? Wala. So, dito ko na lang ilagay. Okay, the last line is line 3. Line, failure line is, tanggalin ko to. A, B, E, and then F. Okay, kung ganyan daw yung magiging fracture line natin, ano yung magiging net area natin. We compute line ABF. Okay? So first, gross area. Your net area is equal to your gross area, that is equal to 279.4 multiplied by 12.7 minus ilang butas? That is equal to dalawa, di ba? At B and E. Okay, so if you notice, that would be equal to your net area din lang. Okay, itong part na ito, minus 2 times 23 by 12.7. Okay, plus, okay, you have to add the stagger kasi meron tayong zigzag dito. Itong line BE. So, ano yung magiging S mo dyan? Still, that is 76.2 mm or 3 inches. But your gauge, okay, that would be from B to E, okay, the vertical distance would be 3 plus 3 inch or 76.2 times 2 or 152.4. Right? So, S squared, S is 76.2 squared divided by 4 times gauge, that's 6 inch or ngayon, 152.4. Okay, multiplied by the thickness, okay, which is 12.7 mm. Okay, so that is the net area. Okay, for line ABEF, please compute. $3,000. Okay, square millimeter. Let me check. Plus stagger 76.2 squared divided by 4 times 152.4 multiplied by thickness 12.7. 3,085 square millimeter. Now, anong pipiliin natin? No? Na-compute na natin yung tatlo. What will govern as our net area will be the least. Okay? Yung pinaka-least na tatlo. So that would be, check mo, 3,085, 2,964, and 2,914. So our governing net area, answer, KN is equal to 2,914 square millimeter. Yan na yung gagamitin natin for the determination of the design strength or tensile strength plus. Huh? O, di ba? Naglaka lang. And then, we still have around 15-17 minutes. Eto. Yeah. So we have a channel, okay, and we are to determine the net area along the route A, B, C, D, E, F. Etong isang route lang yun, no? Or failure line. Okay, for the C15 by 33.9 or with gross area of 10 square inch as shown. So the holes are for 3/4 inch holes. So again, 3/4 inch is 19 mm. No? So 19 plus 2 plus 2. Then the hole diameter natin is, what is this? Diameter of hole, 3/4 inch is 19 mm plus 2 plus 2 or 23 mm. Our gross area is 10 square inches or in square millimeter, that is equal to what? If you look at the section database, parehas lang din yan. C15 by 33.9. Walang lang yan alas. Makikita mo din yung C section. Ngayon, C15 by 33.9. C15 by 33.9 at yung kanyang area ay nandito. That's 6,450 square millimeters. Tama ba? 10 by 25.4 square. 6,452. Okay. Wala namang diferensya, no? That's a difference of 1.6 square millimeters. Six four 50. Ayan. Maglilip kayo mo. Tapusin lang natin to, class. Okay. So, ganito ha. For angles and channels, class. Kapag, ano na nga yun? Asan yung mga butas natin? Eto ha. Ang mangyayari kasi dyan, walang gagawin natin. Gagawin natin silang iisang diretso. Vertical, di ba naka-channel ito. May horizontal ito. Eto, bibinatin natin yan. Papataas. Okay? At anong mangyayari pag bininat mo yan? Eto, hindi yan magiging 1.4 plus 2 tapos idadagdag mo siya na diretso na 1.4 plus 2. No. That would be, okay, saan yan? Ito yung 1.4. And then, pagdating dito, diba dito bibinatin na natin? Itong part na ito. O bibinat yan. At yung magiging length nito, it is not equal to 3 plus 2. But rather, it is equal to, ito, 3 plus 2 minus 0.4. Bakit minus 0.4? Kailangan natin daw ibawas class yung thickness, okay, ng ating channel, which is 0.4 inch. Ganyan yung ginagawa. No? Hindi yung buong didiretsuhin mong 3 plus 2. Okay, that's wrong. You have to deduct the thickness of the channel, or kung angle man yon, you have to deduct the thickness of the angle. Alright, so ganun din dito sa baba. Kailangan minusan ng 0.4 or thickness. So yan, ito na yung diniretso siya. So magkakaibang thickness niyan. 0.65 for the punch and 0.4 for the web. Alright. So, ito yung mga gauges. Ano mga gauge natin? These are the G's. 4.6. Ito 9. And then ito 4.6, no? Magkakaibang G yan. Kaya meron tayong summation. Yan, nandun naman para sa kabila. Tignan natin lagi ito magpagulo lang. That's the gross area. Now we compute for diameter of the hole. We have the thickness. Yeah. Pwede na natin compute yung ating net area. Our net area now is equal to the gross area minus the area of the holes na puputasin natin for the holes plus, okay, the effect of stagger. That would be equal to the summation of your pitch squared divided by 4 times your gauge multiplied by the thickness. Okay? And for such, magkakaiba. Iba dito. Dito hanggang dito. Hindi. Ay, isa naman pala yung thickness na gagamitin natin. Yung thickness ng flange. Losid. Wait lang. No, hindi daw ganun yung pag-compute ng thickness. Should be average. As example yan sa likod. Okay, ito. Our net area is equal to our gross area, that's 6,450 minus area ng holes. O ilang butas yan? 1, 2, 3, 4 bolts. No? But, iba yung taas, tsaka iba yung pinakababa. So, we have 2 times, okay, diameter ng hole, 23, multiplied by yung thickness sa flanges, that is 0.65 inch, or, what is this in mm? 0.65 times 25.4, 10 minutes na lang, 16.5 mm. Okay, 0.4 inch is 10.2, 10.16. And then 16.5 din yun. Okay. So yan. 2 by 23 by 16.5. Yan yung itong taas tsaka babang butas. Minus, dalawa ulit, yung nasa gitnang dalawang butas. 2 by diameter ng butas natin, 23 by 0.4 inch, 10.2 mm. Okay, plus, effect ng stagger natin. Itong una. Okay. So, since dito kasi class, meron tayong, diba, sa B, ito yung B na part, no? Ito yung B na part. Dito. Ito naman yung E. Kung diniretso natin siya, iba kasi yung thickness ng ating flange sa ating web. Okay, so mangyayari, we have, to pag-compute ng thickness na ito, we have to take the average of the two. Okay? So, parehas lang ng S tsaka G ng pinakababa, tsaka itong pinakataas, iba yung sa gitna. So, we have twice of S squared, that is 3 inches, or 3 times 25.4 is 76.2. Twice of 76.2 squared, S squared all over 4 times the gauge. Okay, ano ang gauge niya? That is 4.6 inches, or 4.6 times 25.4, 116.8 square millimeter. Yan, multiplied by half average daw. Kasi dito, meron kang 0.65 and then dito meron kang 0.4. Okay, so you have to consider the average. 10.2 plus 16.5 divided by 2. Okay, and then we have another stagger effect. Yung itong gitna from S to G. Yung consider nating dalawa na to, that is BC tsaka DE. Okay, may CD pa tayo. Plus S squared, that's 3 inches or 76.2 divided by 4 times the gauge. Gauge ng C2D, that's 9 inches or 25.4, 228.6. Multiplied by the thickness ng ating flange. Kasi ito yung C, ito yung D. That's 10.2. Alright, now that is the net area. Okay. Please compute. Less 2 by 23 by 16.5 less anong sagot? Anyone? Copy. 228. Ano? Ano yung screen ko? Ayan. Ano yan? Ewan kong tawag. Copy ka, Vincent? Or ako?
Sir siya.
I-chat mo na lang. Para mabigyan ka ng moment. Sino? is dito. Five, 6, 18. Tama ba na-compute niyo yung class? Ba't sa akin nalaki? Wait lang. May LCD kasi calculate ko. Okay. Tama. 5,618 square millimeters. Okay, so I hope everyone get this or got this answer. No? 5,618. So yun palang class ang pagko-compute ng net area. Meron pang kasunod yan, the computation of our U factor for the computation of the effective net area. Okay, that this is the answer. Nawala pala ako sa screen. Okay, so I guess that would be all for today. On Wednesday, we will continue. Okay, and probably finish analysis on Friday, and then we design next week. Okay, and then module 3 compression members, naman, no, columns. So wala na kayong activity. Tama ba? Yan yung sagot class, 5,618. Alright, so let's meet again on Wednesday, 1 to 3 p.m. Okay, 11:59 na. So attendance, paano ba magkuha ng attendance dito? Screenshot ko na lang. Wait lang, maglilig. I-end ko lang tong presentation para makita ko lahat. So yun. Saka mag-leave ako. Screenshot ko lang. One, two, three. Na tayo mag-open ng cam, no? And save. Date is 2/28/2022. 2/28/2022. So if you guys don't have questions, you may now leave the meeting and let's meet again on Wednesday.
Bye, sir.
Bye
Bye,
po.
sir.
Okay, thank you. Goodbye.